Good afternoon, Mr. Trudy. Professor Dr. Dolphy Gilpin, and I'm here this afternoon as promised to exercise some of the differentials emanating from the new central matrix. And as we know, we are now up to the, which order? 100x1i. That is the 11th order of differentiation there for this century. And so let's formulate some expression, algebraic expression to be differentiated. Firstly, then we hope to formulate some differential equation with some boundary value problems. But let's first do the differentiation. And suppose, for example, here, we could have used any of these parameters here, but since we were using a lot of C's here, let's start off with C, form an expression, C to the 12th, say, plus 7C to the 6th plus 2C to the 4th plus 2. I arbitrarily formulate that expression from my head. And like I said, we could have used any of these parameters coming down. But since C was so dominating through this exercise, we use C. And so we say now that function of C is equal to C to the 12 plus 7C to the 6 plus 2C to the 4th plus 2. So that f dash of C now would be equal to d by dc, and that would be equal now to 12c to the 11th plus 42c to the 5 plus 8c cubed plus 0. And so we say now that f double dash of C equal to d squared dc squared, and that's equal now to 12 times 11 c to the 10th plus 5 times 6 times 7 c to the 4th plus 2 times 4 times 3 c squared. This is for f double dash of x. And for f triple dash rather of c, that will be equal to d cubed by dc cubed, and that will be equal to 10 times 11 times 12 c to the 9 plus 4 times 5 times 6 times 7 c cubed plus something doesn't look right here, 3 times 8. Alright, that's for the 8. 2 times 3 times 8 c to the 1. And so we say now f upper dash of x of c is equal to d fourth by dc d fourth squared. Put it all of f, the function of x. And so this will be equal now to 9 times 10 times 11 times 12 c to the 8 plus 3 times 4 times 5 times 6 times 7 c squared plus 2 times 3 times 8 c to the 0. Anything to the 0 is 1, but we just want to put it like that. And so as we move along, we said now f v of c will be equal to d fifth f by dc fifth. And that's now equal to 8 times 9 times 10 times 11 times 12 c to the 7 plus 2 times 3 times 4 times 5 times 6 times 7 c to the 1, and this will go off to 0 here. Moving along with this differentiation process here, exercising function v1i of c equal d6 of f by dc to the 6, and that's equal to 7 times 8 times 9 times 10 times 11 times 12 c to the 6 plus 2 times 3 times 4 times 5 times 6 times 7 times 1. As we go along, we have f function v y of c or f dash of c, f7 equals now to d7f by dc7, that's equal to 6 times 7 times 8 times 9 times 10 times 11 times 12 c to the 5 plus 0. Still going along, you know that F V1, 2, 3 of C, that is differentiating to the seventh time of the seventh order, rather of the eighth order here, this will be equal to D8F by DC8, and that's equal to 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12, C to the fourth. As we reach here now, we just want to tell a little story of this calculus, Newtonian calculus. We know that the word is spelled C-A-L-C-U-L-U-S. And we know that over a course of time, they said a lot of loss came into calculus. As if the word was calculus. And so what is desired is that we return to calculus pure. Calculus pure, when we take out the loss from the calculus. But that's the English language, and we get calculus pure. And from that we have pure mathematics. When mathematics was indeed pure and there wasn't a lot of loss. The loss have taken over the world so much now, everybody can do it, the calculus, because they're lost thing. But we need some calculus pure, or some pure mathematics, with some ethics and morality. Let's move on. That was just a little aside story. F to the ix of C, that's now equal to D9 of C, D9 of F by DC9. And that's equal to 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 C cubed. And we notice that after the century, what we had was X1I dash. So that we could go to F of X of C, differentiating 10 times, equal to D10F by DC10. And that's equal now to 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 C squared, and last of all F X1I dash of C, meaning differentiation to the 11th time, now equal to D11 of the function by DC11, and that's equal now to 2 times 4 times 5 times 6 times 7 times 9 times 10 times 11 times 12 C to the 1. And for the configuration of the matrix itself, we do to the 12, so that we have F of X for the X 2I dash of C equals D12 of F by DC12 equals to 2 times 4 times 5, 1 times 2 times 4 times 5 times 7 times 8 times 9 times 10 times 11 times 12 C to the 0. But then we know anything to the 0 is equal to 1. So actually this is times 1. And therefore we have it. And if we should differentiate to the 13th order, we get 0. So we have f x 1, 2, 3 of c will be equal to d 13 of f by d c 13, and that will be equal to 0. So we have completed the exercise of the differential order that came up through this new central matrix to the 12. And let's just do a magnified view of it here. This was just the story told over here with calculus and calcupure and pure mathematics. A little story there. And we start off with the expression. Let's write it in here. F dash of c is already there. F of function of c is equal to that function of c. And so we start from f1 of c to x13 dash of c, and we differentiated in that order. So I have to just, okay, so there we have it.